So why should we start from section
Um,
1? Have you done section 1? 7.1.
I had a question about number 11, part A and D,
Mm-hmm.
and then we'll move on to section 2.
So number 11, we are given that for a random sample of 60 overweight men, the mean of the number of pounds they were overweight was 30. The standard deviation of the population is 4.2 pounds. Find the best point estimate of the average number of excess weight that they weighted. The best point of estimate is the sample mean. Each time you have a question about the best point of estimate for the population mean, it is the sample mean. So do you know what the sample mean is here?
60.
No, read the question again.
Oh, the mean
60 is the sample size. What is the average?
is 30.
30. So
am I using the margin of error formula again?
yeah, for B and C, you need the margin of error.
Okay.
So because the standard deviation of the population is given as 4.2, you need to find the margin of error using the formula E equals to Z alpha over 2 times sigma over square root of N. Here, Z alpha over 2 for 95% is 1.96. And for 99% is 2.58.
So for 11, is the answer just 30?
A, question A, the answer is 30.
Oh. Okay.
And question, could you do question B?
I already did B and C.
So which of the two has a larger interval? To determine the larger interval, you just want to determine the larger interval, take the upper number minus the lower number. That will give you the distance of the interval. But generally, for a 95% confidence interval, Z alpha over 2 is 1.96. But for 99 is 2.58. Because 2.58 is bigger than 1.96, it will give you a larger interval.
Oh.
So for confidence interval, the more confident you are, the larger the interval is. For example, I am 100% confident that your age is between 15 and 30. Do you understand what I mean?
Yeah.
If the wider my interval, the more I am sure that I'm going to get the parameter in that interval. So the smaller the interval is, then the less chance I have to have the interval, so the less confident I am that the interval will contain the parameter.
Okay. 21 I didn't solve yet, but I got your email, so I'm able to do that.
Which one? 21?
Yeah, 21 in section 1. I got your email from last night, so
yes,
we don't have to go over that.
Yeah, okay.
Next was number 15 in section 3, or on page 3 of 79 to 380. It was question 15.
Question 15. So for a group of 12 men subjected to a stress test situation, the average heart rate was 109 beats per minute. So you can see the sample mean, right? Sample mean. Can you tell the sample mean at this point?
109.
109. It says that for a group of 12 men subjected to a stress test situation, the average heart rate was 109 per minute. So the sample size is 12 and the sample mean is 109. And the standard deviation was 4. That's the standard deviation for that sample. So because the standard deviation of the population is not given, we are going to use the t distribution to compute the margin of error. So to find the t alpha over 2, we go to the table in page 652.
Okay.
In page 652, we want a confidence level is 99%. And sample size is 12. That means the degree of freedom is 11.
Yeah.
So we go under 11 and move to confidence interval 99. Can you see the t alpha over 2?
3.106.
3.106. So you now use that 3.106, then multiply it by s, the standard deviation 4 over 2, and divide by square root of 12.
Standard deviation was 4. So the 4 goes on top, right? The s is the standard deviation.
The standard deviation is 4, yes. So you will do 4 divided by square root of 60. Then the answer, you multiply it by the t alpha over 2 that we just read. I think you say it was 3.
I thought the n was 12.
Oh, sorry, the 10 of, yeah, you are right. N was 12. I'm still having the previous question. Yeah, divided by square root of 12. And
Okay.
multiply by the t that you had. That's very good. You are following what we are doing.
Okay.
3.106. We multiply it by 3.106. So this is the margin of error. So we will subtract it from the mean. 109 minus 3.59.
I got 105.41.
Yes.
And then you do 109 plus 3.59.
Yes.
So how when like I'm reading the problem, how do I know which formula to use?
Okay, if it is about the mean, you have either the Z formula or the T formula. You choose the Z formula when you are told that the standard deviation of the population is. All the problems in 7.2, you had that. The standard deviation of the population is. Like on that 11 we just did, it told you that the sample mean was 30, the standard deviation of the population is 4.2. In this problem, the word population is not there. You are just told the standard deviation was 4. When you are given the sample mean and the standard deviation, that standard deviation is for the sample. And it means that the standard deviation of the population is not given.
Okay. Okay. Then now it's just going to section 4.
Yeah, which section?
Pages 387 to 388.
Okay. What number?
Just starting with number 1.
Okay. So this is a good question to start with. We want to find the sample proportion for cases where we are given the number of success and the sample size. What is the proportion of success? So if x equals to 40 and n equals to 80, what is the proportion of success? X is 40, n is 80.
I don't know what that means.
Okay, the proportion is the number of success divided by the total. Is x divided by n.
Oh, so if you're looking for P, okay. So 40 divided by 80.
Mm-hmm.
0.5.
0.5. And Q is the proportion of failure. If the proportion of success is 0.5, what is the proportion of failure?
1 minus 0.5.
Yeah, which is 0.5.
Yeah.
So second question, x equals to 90, n equals to 200.
Oh, okay. Okay, so these are not that bad then.
Okay. Yeah, easy question. You find P. To get Q, you do 1 minus P.
Yeah. Okay, so we could move on then to the next question. 3.
So in 3, a survey of 1,000 US adults found that 33% of people say that they would get no work done on Cyber Monday since they would spend all day shopping online. Find the 95% confidence interval of the true proportion who don't work on Monday, the Cyber Monday. That's our question. So the formula here for the margin of error is Z alpha over 2 times square root of PQ over N. So you need to find what is P, what is Q, multiply P by Q and divide by N. Then you take the square root. After that, multiply what you get by Z alpha over 2. And remember the Z alpha over 2, for 90, 1.65. For 95, 1.96. For 99, 2.58. For 98, 2.33. There's one of the slides on the PowerPoint that has that.
Yeah.
So what is P here? What is the proportion of success in this problem? There is a proportion given in the problem. That's the proportion of success. Can you identify it?
The 33%.
33%, but you are going to write it as 0.33.
Wait.
So to work with the percentage, with the proportion, change it into decimal. Instead of 33%, use P equals to 0.33, 0.33.
Oh, because I was still trying to find the Z number.
Okay, the Z, oh, you are looking for it on the PowerPoint?
Right, 1.96.
Okay, yeah, 1.96.
So then that P becomes 0.33.
Yes, and Q?
0.67.
0.67. Now you will do 0.33 times 0.67 divided by
And
n, yes, and then take the square root.
is that just, wait, did they give us the N or no?
Yes, n was 1,000, a survey of 1,000.
Okay. Mm, I just don't know how to put this into the calculator.
What do you want to put into the calculator?
Well, after I do 0.33 times 0.67, and then I divide that by 1,000, I get like 2.211 with an E minus 0.04,
Mm-hmm.
and I don't know how to square it.
Okay, so because this number is small, it's actually 2.211 times 10 raised to power minus 4. That E is like 10. But another way to do it, to avoid that decimal, that way of writing decimal, okay, you can do square root of 0.2211 first. Can you do that one?
Square root of which?
When you did 0.33 times 0.767, it will give you 0.221,
Yeah.
0.2211. You take that square root.
Okay.
Then you divide it by square root of 1,000.
Okay.
Do you know how to do division by square root of 1,000?
I got 0.014.
You got what?
0.015.
Okay, 0.015. Then multiply it by 1.96.
0.029.
Okay. Now, that is the margin of error. So P hat is 0.33. That's the point estimate is 0.33.
Oh, 0.33
Yeah, 0.33 is the point estimate.
plus 1.96.
No,
No.
don't do that. You have already use 1.96 that you multiply by that square root of PQ over 1 over N. Remember?
Oh.
And you got 0.015. You remember, you just told me now you got 0.015.
Oh. Point. So it's the 0.33.
0.33 is the sample proportion. You will subtract the margin of error from it and add it to it.
Oh, okay, I get it. I wrote the formula wrong.
Okay, but I think what you did to some extent was correct. When you did 0.33 times 0.67, then took the square root and divided by square root of 1,000. That was, you were doing it separately so that you don't have the trouble of that e raised to power minus 4. You can just do it again, 0.33. 0.33 times 0.67. You will get 0.221. And you take the square root of 0.2211. Then you get 0.47, and you divide it by square root of 1,000. Then you will get 0.0148. Now this 0.0148, you will multiply it by 1.96.
Yeah.
And that's the margin of error.
But I still have to subtract 0.029 by 0.33.
Yes.
Okay, so that 0.33 minus. So it's 0.301.
That's good. It's the lower value. And then that 0.029, you add it to 0.33 to get the upper value.
Uh, 0.359.
Good. That's the correct answer.
Okay. Did you ever get a negative number for these or no?
It could happen, but it just means that there might be the proportion could be 0, but that is not too likely. But it could happen because mathematical computation, and it just means that the proportion could be 0.
Okay.
But oh, you got a negative number because you did the wrong subtraction. You said it and I did not correct because I expected that you, if you do 0.029 minus 0.33, you will get the same answer but negative. You are supposed to do 0.33 minus 0.029.
I did. I was just asking for any future problems.
Okay. Anyway, when you get negative number, check again. It's not common to have negative number except for the difference of two proportions.
All right. So is number 5 the same?
Yes, number 5 is essentially the same. P in number 5 is 0.68. Confidence level is 90, so Z is 1.65, and the sample size is 100. So you are going to do 1 minus 0.68 to get Q, okay, and do essentially the same thing.
Okay. How about number 7?
In number 7, Research by Steelcase found the average worker get interrupted every 11 minutes and takes 23 minutes to get back on task. From a random sample of 200 workers, 168 said they are interrupted every 11 minutes by email, text, alerts. Find a 90% confidence interval of the population proportion of workers who interrupted every 11 minutes. So in each question concerning proportion, you want to know what is the sample proportion. To determine the sample proportion, you want to know what is the sample size. Can you tell the sample size here?
200.
200. The sample size is 200. And the number of success, the number that satisfies the proportion we are looking for?
90.
No. How many people interrupt every 11 minutes out of the 200? That is the number of success.
Oh, 168.
168. So you will do P equals to 168 divided by 200. So that's how you will find P. P. And now Q is 1 minus P, and you do P times Q. All of these are P hat, Q hat. I'm just saying PQ. You multiply P by Q, divide by...
P is equal to 168 over 200?
Mm-hmm.
Okay.
You will get 0.84. And then you subtract it from 1 to get 0.16.
Okay.
Remember that here you may still have that E minus 4. To avoid it, you can do the square root of the P times Q, then divide by the square root of 200.
So this one's still with the Z, right?
Yeah, the Z here is 1.6. After doing NP, square root of NP over Q, you multiply by 1.65, which is the Z. Is it okay? Are you doing it?
I'm still... Wait, to solve it, to avoid that, it's 0.84 times 0.16.
Mm-hmm.
Do I square that answer first?
Take the square root of that answer.
Of 0.1344.
Then divide that by square root of 200.
0.026.
Okay. Then multiply that by 1.65.
Okay. Point 0.42 or 43.
Mm-hmm.
Then subtract that by 0.84.
No, then subtract that from 0.84. That's the margin of error. You will now do p hat minus e, p hat plus e. P hat is 0.84.
Yep.
So you will do 0.84 minus 0.043. And then
0.779.
yes.
So then the other one would be 0.84 plus 0.043.
Yes.
Okay.
So when you are dealing with proportion, you should be careful about rounding up. You are doing it well so far because you are rounding up to the third decimal. You know, proportion are very small numbers between 0 and 1. So when you are rounding up, round it up to the third or fourth decimal.
Okay.
I mean, let's put it as you have been doing, be at least to the third decimal. You understand? Because they are very small numbers. Yeah, so that is the correct answer. And when you have multiple choice, choose the answer that is the closest to what you have, because you might be doing some roundup and then it might not be exactly the same. I'm not saying it's going to be like that all the time, but answers sometimes with confidence interval may not be exactly the same because it could depend on how you did the roundup. But continue to round up to the third decimal. You will see, when you see numbers, you can't feel how you can round it up. If there is too many decimal like 0.000, you want to have at least 2 or 3 significant numbers.
Mhm. Okay. Is number 11 the same?
Yes, number 11 is the same as number 3 and 5. Because you are given the proportion. So the difference between 5 and 7 is that in 3, 5, you were given the proportion. In 7, you were given the number of success, and you use it to find the proportion. Do you understand what I mean?
I think so.
Yeah, like we did 168 divided by 200. Meanwhile, in the other questions, we had 0.33, the proportion was given.
Okay.
In question 5, we had 68%, so the proportion was given. You did not need to compute the proportion.
So 15.
We go on 15?
Yeah.
Okay. 15 will be different from what we have done so far. So in 15, we will be looking for the minimum sample size. There will generally be 2 types of questions with minimum sample size. In one of the questions, an estimate of the population proportion will be given, and the other one, it will not be given. When it is given, you will use it as P. When it is not given, you will use P as 0.5. So the general formula for the minimum sample size is that N equals to PQ times Z alpha over 2 divided by E. So let me show you on the PowerPoint which slide will give you that formula.
You said the minimum?
Minimum sample size, yes. This question is about minimum sample size. You can see it in slide 37.
Okay.
So there you will have P and Q, and those P and Q, P is just, once you have P, you have Q. Q is 1 minus P. So let's look at the problem now. Are you ready?
Well, I just wanted to know how did you know that we're using this formula?
Because you will be asked to find the sample size. When you are asked to find the sample size, that is when you use this formula.
Okay.
Because the margin of error is given to you. In confidence level, confidence interval, you use the sample size to get the margin of error. In this problem, you will use the margin of error to get the sample size. You understand what I mean?
Uh-huh.
So let's look at 15 then. A researcher wishes to be, are you with me?
Yeah.
A researcher wishes to be 95% confident that her estimate of the true proportion of individual who travels overseas is within 4% of the true proportion. So that is the margin of error. That is the estimate you are going to get is not going to be different from the true proportion by more than 4%. The margin of error is also called the maximum error of estimate. So the margin of error here is 4%, which is 0.04. When we are using it to do computation, we change it into proportion, which is 0.04. So you can write down that E equals to 0.04.
Okay.
So we have E, and we have confidence level is 95%. So Z alpha over 2 equals to 1.96.
Okay.
So what we don't have here is P, because if we have P, Q is 1 minus P. So find the sample necessary if in a prior study, a sample of 200 people showed that 40 traveled overseas last year. So that means there was a study before, and that will serve as our estimate of the population proportion. So from that experience of last year, out of 200, 40 traveled overseas. So an estimated proportion is 40 over 200.
Oh, because the 40 over 200, is that going to give us P?
Yes.
Okay.
So what do you get?
0.2.
0.2. So if P is 0.2, what should be Q?
0.8.
0.8. So you are going to do Z alpha over 2, which is 1.96, divided by 0.04, then square it and multiply by 0.2 and multiply again by 0.8.
Uh, 384.16.
384.16, so round it up to 385. That's
Okay.
correct. And remember the formula, Z over E all square times P times Q.
Yeah.
So now, if no estimate of the sample proportion is available, how large should the sample be? That means, suppose we were not told what happened last year, then you will make an estimate of P to be 0.5 and Q to be 0.5 and use that formula.
Why 0.5?
Because there is no estimate of the proportion, we use half. Always when there is no estimate of the proportion, that is, you have no knowledge of what has happened in the past, you take 0.5. There is a mathematical explanation to that, but it's not at your level to understand. So just take it as 0.5. When P is not given, use P equals to 0.5.
So we have to solve it again?
You have to do 1.96 divided by 0.04, square it, and divide by 4, or multiply by half times half. Half times half is 1/4.
Wait, so for the second one, it's 0.5 times 0.5 over, or times 1.96 over 0.04 squared. 6003.
600.3. There's a point there, right?
I got 6002.5.
600.
2.5.
No, I think there is a decimal that you are missing. 1.96 divided by 0.4 divided by 0.04 is 49.
Oh, I did not add in the other. What?
You should get 600.25.
So there's two numbers on the bottom of the division sign?
Yeah, it was 1.96 divided by 0.04. Remember, the margin of error was 4 as a proportion, 4%.
Yeah.
So you did it well the first time. The 4% is 0.04.
Oh, I guess, yeah, I put it wrong. 600.3.
Okay, then you round it up to 600. Always round up sample size to the whole number.
Okay.
Sample size is a whole number. Don't say that sample size is 600.25. There is no individual that will be 0.25. Is that okay?
Yeah. So 17 the same?
Yes. That's how you do. Each time, if you look at the next question, they will ask you separately. They will ask for A, no estimate is given. B, I'm sorry, A, they give you a form of estimate. And B, no estimate is given, like number 16. So you will be given two types of questions here. When an estimate is given, you use that estimate as P. When no estimate is given, you use 0.5 as P.
Okay. And then I guess we could go to the last section.
The last section, we will take a deep breath here because it is not like what we have been doing. So let's start with the first question. I think that is what you have. Maybe number 3 should be the first question, I think.
I have number 1 as the first question we did.
Okay, number 1, it is a quick question. What distribution must be used when computing confidence interval for variance and standard deviation? Do you know the distribution for variance and standard deviation?
No.
Chi-square. Remember that?
Yeah.
Chi-square. CH, we read it as chi.
Okay.
CHI, chi-square. Okay. We will have to find chi-square left and chi-square right. If you know how to read the table to get chi-square left and chi-square right, now you are good for that question. That's the difficult part, how to read that table.
So the answer for number 1 is just chi-square.
This is the chi-square distribution.
Okay. Okay, so number 3.
Okay. In chi-square distribution problems, it's a right tail distribution. So you are given alpha, but sometimes you are given the confidence level. In each of these questions that we have here, you are given alpha. When you are given confidence level, alpha is 1 minus confidence level. I want you to notice that. If you are given a problem, if you are asked to find a 95% confidence interval for variance or standard deviation, know that the alpha for 95% is 5% or 0.05. Alpha for 90% is 10% or 0.1. Let's start with that, knowing what is alpha. Alpha is 1 minus confidence level. Do you get that?
1 minus confidence level. And what's n?
N is sample size.
Okay.
Okay. When you want to read the chi-square left, chi-square right, you will do alpha over 2. Alpha over 2 is for chi-square right. 1 minus alpha over 2 is chi-square left. Let's start with number 1. Alpha equals to 0.05. What will be alpha over 2? Alpha divided by 2.
Is it just 0.05 divided by 2?
Mm-hmm.
.025.
0.025. And then you do 1 minus that.
.975.
0.975. So for right is alpha over 2. For left is 1 minus alpha over 2. So for right is 0.025. For left is 0.975. If you understand how to get those numbers, that's the key to solve questions in this section.
You said to the left is 1 minus or no?
1 minus alpha over 2.
Is for the left.
Yes. If you have those two numbers, then we will go to table G.
I have table G. I just.
You have table G. So now, for question 1, alpha is 0.05, n is 12, so the degree of freedom is 11. N minus 1. Degree of freedom is n minus 1. Do you understand?
No.
Remember, degree of freedom that we have learned so far is n minus 1.
Are we using table G still?
Yes, we use that degree of freedom n minus 1 both for table F and table G, both for the T table and the chi-square table, both for
So
the
am
T
I?
distribution and the chi-square distribution.
So am I looking at 12 and 0.975?
No, 11. N is 12, n
Oh.
minus 1 is 11.
Oh.
So
3.816.
that's chi-square left. You can see that it's at the left of alpha. You see alpha on top? The first row, you see alpha?
Yeah.
So we have left of alpha and right of alpha. So chi-square left is 3.816. And then on that 0.025, you will have chi-square right, which is what?
Wait.
Under 0.025 for right. Okay, we are under 11. Do you see 11? Degree of freedom 11.
Yeah.
First, you see 3.816, right?
3.
Under
Yeah.
0.0975.
Yeah.
That is for left. You go down to 0.25 to get for right. Still
So,
with 11.
11 and 0.025.
Yes.
21.920.
Yes. So that's chi-square left and chi-square right. Let's do another one for practice.
Okay.
Use any other letter there.
I'll just do B.
Okay, let's do B. What is alpha?
I'll write it down. Alpha is 0.10. N is 20.
So degree of freedom, once you write n equals to 20, right near it, df equals to 20 minus 1 equals to 19.
Right.
Then alpha over 2.
Is it always going to be over 2?
Yes. Over 2, you will understand it better when we get to chapter 8. This over 2 because it could be left or right. So that's why we are dividing half of alpha to the left, half of alpha to the right. If you like, I can explain that to you. Do you mind knowing why we do alpha over 2?
So 0.10 over 2. 0.05, is that to the left?
when alpha over 2 is left. You see, look at this board.
The 0.05 is to the left. Oh.
So the chi-square distribution is a left tail distribution. Is a right, is skewed to the right. So this part is alpha over 2. And this part to the left is alpha over 2 also. Okay? But let me see if I can have color here. So, but what happened is that chi-square right is here. Let me just put R. And chi-square left is here. So the alpha and that you see on top of that distribution is the area to the right of alpha. Is the area to the right of chi-square. So when you look at chi-square right, the area to the right of it is alpha over 2. When you look at chi-square left, the area to the right of it is 1 minus alpha over 2. Do you see my diagram?
Yeah.
So the area to the chi-square is identified with the area to the right of it. So that's why for left, we are doing 1 minus alpha over 2. So the table was not meant for this chi-square left, chi-square right. It's for many things involving the chi-square distribution. Now, going back to what we have, we are saying that if you have a distribution, you want to find what is alpha over 2 and what is 1 minus alpha over 2, so as to know the area to the right. So in this case, alpha is 0.1 and alpha over 2, 0.05. What is 1 minus alpha over 2?
And that 1 minus alpha over 2 is that one, the 0.95, that's for the left.
Yes, that's for the left.
Okay.
So we go back to the table.
Okay. So it's 19.
Yes.
And if we're looking for the left, it'd be 0.95.
Yes.
10.117.
And if you just go symmetric to that with respect to alpha, if you understand what is the word symmetric, you will get the other one. That is, the middle is alpha. So once you get the left, you just go the same distance as you were, you will be at the right position. What do you have? Under 0.05.
30.144.
That's good. You want to do another one?
I think I have it because I've been writing it all down.
Okay. So once you have alpha, you can have chi-square left and chi-square right. And now, when you have confidence level, know that alpha is 1 minus confidence level.
Yeah.
Then, what do we do? How do we find the confidence interval? Confidence interval is, the formula is n minus 1 multiplied by s square, which is the sample variance, divided by chi-square right, less than or equals to sigma square n minus 1 times s square over chi-square left. So once you have those two numbers, find the confidence interval, just multiply degree of freedom by variance divided by chi-square right, and then degree of freedom times variance divided by chi-square left. You will get the two numbers that defines the confidence interval.
Okay, I'm gonna write that down. Is there going to be like a number there for the, what is that? The sigma squared?
S square. Yes.
The little circle squared, like, are we
No,
gonna?
we don't need it because that is what we want to estimate.
Oh, okay. So there's
That's
not
at the middle. We are sandwiching it by those two numbers. So
okay.
what we need is the sample variance, S square.
Okay. I got it. So let's look at it. Number 5. Am I gonna have to use Excel for this?
Number 5, you will use Excel because we want to compute the mean and the standard deviation of the sample.
So do we have to use any chi-square or anything like that in this problem?
Mm-hmm.
Oh,
So I will explain how to do 5 and we will do 9. To do 5, what you need is the sample variance. All what you need is sample variance. If you know how to compute the sample variance, then you will be able to do 5. Oh. Hello? Sophia?
Hi.
Hello, did you miss the time? Because it was, did I say 6 to 7 or 5 to 6?
6 to 7.
I said 6 to 7?
I'm sorry. Yeah. You did say 5 to 7.
Oh, mistake was mine. Anyway, you are welcome. We will look at your questions quickly. We are almost done with Rosalinda, but we are now on 7.5. So you may just join us there. But we have recorded, we have gone to homework for each section already.
Okay.
So, and we are recording it. So we are now on 7.5, number 5. So we have, either we use Excel. Do you want us to just practice Excel quickly?
I know how to put in all of the numbers to get like the mean and the sample and the confidence level.
But when you do Excel, you want to know that what you get there is S, not S square. You have to square it because Excel gives you both. I think Excel will give you both.
Okay, so we can go over that.
Yeah, let me just, this is what we did on Excel last time. So when you put the data and use Excel, Sophia, if you don't know how to use Excel, I can do it when we are done with Rosalinda because she has been here for more than an hour now. So when you use Excel, it will give you this. And this, the second one, sample variance, is what you will use in the formula. So let's do number 9 because,
what we're using.
Pardon?
The sample variance is the one we're going to use.
Sample variance is S square. You see that formula has S square. If you use standard deviation, square it. If you use sample variance, just take it as it is.
Okay.
To avoid confusion. S square is sample variance. S is sample standard deviation. So let's look at number 9. Then you will be free to go if you want to go. Yeah. So are we together on number 9?
Yeah.
Sophia, we are on number 9, page 376.
Okay, thank you.
Yeah, so the standard deviation of a sample of 15 automobile repair at a local garage was 120.82. Assume the variable is normally distributed. Find the 90% confidence of the true variance and standard deviation.
Okay.
So, we want to find, this is the formula for confidence interval. So what we need is chi-square left and chi-square right. Let me erase this. So what is the confidence level here?
90%.
90%. So what is alpha? Alpha is 0.1, 10%. Alpha over 2?
Alpha is 0.10. The 0.5 is to the right, or the 0.05.
Mm-hmm. So we need the sample size, which is 15, and the degree of freedom, 14. We now go to the table, table G, in page 654. If your book is new, you may have the formula sheet inside your book. At the back of your book, you will have the formula sheet that has the table also. So that's what I generally use. So table G.
Let's see, 14 and 0.95. 6.571 for the left. Is that correct?
Yes.
.05 and 14. 23.685.
23.685, yes.
Okay.
So those are the two chi-square left and right that we will need. Now, there is a number we can compute for both, is 14 times variance. Do you know what the variance is here? Or what is the standard deviation? You start with the standard deviation of a sample of 15 is 120. 120.82.
Wait, the 120.82 is what the standard deviation?
That you can see from the beginning of the problem. They say the standard deviation of a sample of 15 automobile repairs at a local garage was 120.82.
Okay.
So you square it and multiply it by 14.
Okay, so it's n minus 1 times 120.82 squared, yes, over 6.571.
Yes.
But we don't, but the n in this case is 15.
You are no more using n, but n minus 1, remember that. You are not dividing by,
So it would pretty much just be the 14.
I don't know what you are talking about now. Can you say it again?
I'm reading off the numbers as if they're put into the formula. Is
n minus 1 s square
minus 1
over chi square right. Sorry, chi square.
I was starting off with chi-square left.
The first one you can do chi-square left is the same number that you are going to divide for chi-square right. So if you want to put it in the formula, right comes first because it is bigger.
Okay.
It is bigger at the denominator, but it will produce a smaller number. So let's just get back at the same point. We did s squared times 14. That was 120.82 square times 14. Do you remember that?
Yeah.
And it gave 24, 43, 64.61. Now divided by chi-square right. Do you remember what chi-square right was?
0.05.
No, chi-square right. Confidence, I'm sorry, degree of freedom 14, you had 23.685.
Oh, yeah.
So now the same number you will repeat here.
Like chi-square. Oh my gosh. There's so
Now
many.
divided by chi-square left, which is 6.5. So, are you with me?
Yeah.
So, I think Sophia is gone.
So for the right side, I got 8628.44.
Yes.
And for the left side, I got 31100 point, like not, I'm sorry, 31101.
3110. Okay.
So are those two the answers?
The confidence interval have upper and lower answer. Down, they will ask you for standard deviation. Do you know how to get the confidence interval for standard deviation from the one of variance?
No.
You take the square root. Standard deviation is the square root of the variance.
So we just found the variance intervals.
Yes. We just take the square root of both numbers.
Okay. I got a 93 and 176.4.
Okay. Can you see it on the board?
Sorry?
Can you see my own answer?
Yeah.
Okay.
Okay.
Okay, thank you so much. And as you always know, we record it. I hope you don't mind because some other students will use it. Sophia has left. I think she will be able to use it also later.
So
Thank you.
what we just did for number 9, I can do the same thing for 5.
You can do the same thing for 5, but you will need to find the sample standard deviation and variance using Excel.
Okay, yeah. And all of this stuff will be on the quiz.
Yes. On the quiz, you will have questions like find the chi-square left and the chi-square right if alpha equals to this and that. And sometimes, I'm not sure, you might have maybe one question about confidence interval. But sometimes I give you, if the confidence interval for variance is this, what's the confidence interval for the standard deviation? But practice doing this. That is very good to know.
Okay.
Okay. Okay, thank you. Have a good evening.
You too. Thank you.
Thank you.